Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at Central News Institute of Technology and Management, Gurgaon. This college is affiliated to Maharaji Dayanand University, Rohtak. So today our topic will be equivalence relation, and before equivalence relation, I just want to discuss Fibonacci series topic again. And in this topic, there are 2 marks question always asked in your final semester exam. So I just want to discuss that question in our Fibonacci series, right? So let's see in Fibonacci series, right? So first one is order of recurrence relation. So basically we will just learn recurrence relation, and there are 3 to 4 recurrence relation: LHRR, LHRR, WCC. I will discuss in our next video lectures all these relation. But there is a 2 marks question here, so that is related to order of recurrence relation. So the difference between the highest and the lowest subscripts of fx is called the order of the recurrence relation, right? So basically the definition is highest and the lower power relationship, right? So there is an example here, and I just want to discuss that example with you. Find the first 5 terms in term of this equation. This is your 2 marks question, and this 2 marks question always asked in your final semester exam. So just prepare 2 marks question. Find the first 5 terms of the sequence. If that question is that type of question is given, that means find 4 terms for first 4 terms, find first 5 terms, find first 3 terms, and there is a relationship. This is a recurrence relation, and this always be given in our exam. And an is equal to 3an minus 1 plus 4an minus 2, and n is greater or is equal to 3. So this is your relation, and we need to calculate our first 5 terms. So a1 is given, a2 is given, so we will calculate a3, a4, a5, a6, a7 now, right? And it is given a condition here: n is greater or is equal to 3. That means our series will start from n is equal to 3. So our relation is an is equal to 3, an minus 1 plus 4an minus 2. So put n is equal to 3 here. So if you will put n is equal to 3 here, you get a3 is equal to 3an minus 3 plus 4an minus 4, a3 minus 2, right? So basically we have a3, a2 plus 4a1, and we have our values a1 and a2, so that values are given. So just write here. So 3 into 5 plus 4 into 0. So a3 is your 15. So this is your our first term. Now next is again put n is equal to 4. So n is equal to 4, you will get a4 is equal to 3a4 minus 1 plus 4a4 minus 2. So 3a2 plus 4a2, that means just write values here. So your answer is 65. So a4 is equal to 65. This is your second term. Now put n is equal to 5, then you will get a5 is equal to 3a5 plus 4, sorry, 3a5 minus 1 plus 4a5 minus 2 is equal to 3a4 plus 4a3. So a4 is given, a4 we have 65, a3 is given 15. So just write all values and you will get a5 is equal to 255. So same as put n is equal to 6, then you will get 3a6 minus 1 plus 4a6 minus 2. And just write the values here and put n is equal to 7, then you will get your last fifth term, right? So there is a 2 marks question. So there was a 2 marks question. So guys, just prepare this question. I will share 2 or 3 more questions of this type in our next videos. But now next we have about the next topic, equivalence relation. So just see equivalence relation, right? So equivalence relation means I think in 12th standard you studied equivalence relation. You have already read this equivalence relation, right? So before equivalence, I just want to define this set definition, right? So set definition is a collection of well-defined and well arranged distinct elements, right? A collection of well-defined and distinct elements. So this is called the set. That means in the definition of set, we should have our arrangement must be well defined and must be arranged in a sequence, right? So this equivalence relation. So we need a set here. That is why I discussed set definition. Now, example set of natural numbers. If you want to some examples, if you want to get some example, then set of natural numbers, set of integers, right? Set of cities name which is starting from the alphabet A, right? These are these set because these are well defined and well arranged. Now, equivalence relation. So, equivalence relation means a relation between elements of a set which is reflexive, symmetric, and transitive. So, this is also basically definition means if you have a set and the element of the set, that means the objects of the set, elements of the set, which if we are related to each other, if we are related to each other by the relation reflexive, symmetric, and transitive. If three of the if three all of the condition are satisfied, then we can say that the relation is called equivalence relation. That means for the equivalence relation, these three conditions must be satisfied: reflexive, symmetric, and transitive. These are the three properties of equivalence relation. So definition is a relation, and that relation is denoted by capital R. A relation R on a set A is an equivalence relation if and only if R is reflexive, symmetric, and transitive. It is generally denoted by this sign. This is your equivalent sign, right? So that is called equivalence relation sign. Now, what is reflexive property? So first need to define reflexive, then symmetric, and transitive. So first one, reflexive property. So suppose you have a set A and the element of the set A is small a, and one thing I just set is always denoted by capital letters, right? Never denoted by small letters. Set is always denoted by capital letters, and element of the set always denoted by small letters, right? So capital A is the set and small a is the element of that set. So if A is related to A, that means if A shows showing a relation with itself, then it is called reflexive relation, right? That means that element is related to self. That means this property is called reflexive. And now second, symmetric. So if A is related to B, if you have two elements A and B and which belongs to set A, then you can say that if A is related to B, then B is also related to A. That means if this property is satisfied, then it is called symmetric. Now, third one is transitive. Transitive means you need three elements here. So there are A, B, C. There are three elements belongs to set A. Then if A is related to B and B is related to C, then you can say A is related to C. That means first one is related to second one to third one, then first one will related to third one, right? Or you can write it A is related to B, B is related to C, then A is related to C. These are R is the relation. Now, if these three conditions are satisfied, then our relation will be equivalence relation. But if one of the condition does not satisfy, then our relation cannot be equivalence relation, right? If reflexive is not satisfied, then it's not equivalence relation. If symmetric is not satisfied, or if transitive not satisfied, then our relation cannot be equivalence relation. That means all the three properties must be satisfied, then our relation will be equivalence relation. Now there is an example here. Show that the relation R in the set 1, 2, 3 given by R is given. That means relation is given 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. Set is denoted by capital letters, and elements are denoted by small letters. And one thing, if you are writing a set, then you will write it into small brackets. Curly bracket. So this is your curly bracket. This one and this one is your curly bracket, right? And you are writing a set, then it will be inside the curly bracket, and this is your relation. So relation is will write in the small brackets, and we will add a comma also here. So 1 1 2 2 3 3 1 2 2 3. This is a relation. So we need to check that if this relation is reflexive but neither symmetric nor transitive. So our target is to check this is this is reflexive but not symmetric, not transitive. So first one, what is what is reflexive property? Reflexive property is if you have an element and that element is related to self one, then you can say reflexive relation has exist. So first check, since relation R has elements 1, 1, 2, 2, 3, 3. That means 1, 1 means 1 is related to 1. That means 1 is satisfied reflexive property. 2 is related to 2. That means 2 is satisfied reflexive property, and 3 is related to 3. That means 3 satisfied reflexive property. That means all the three elements of the set 1, 2, 3 are satisfied reflexive property. Then we can say that set A is reflexive, right? Just try to understand, if you have a relation of this type and the relation is given 1 1 2 2 3 3, that means all are element related to self. That means R is reflexive. Now second property is symmetric. So for the symmetric, if you have three elements, that means 1 is related to 2. That means 1 and 2 are coming together. That means this 1 or 2 bracket is given. But the symmetric property also B is related to A. So 2 is related to 1 is given here or not in this relation? 2 1 is not given here. So it is not symmetric. There is relation R has 1 2, but it does not have 2 1. That means 1 is related to 2, but 2 is related to 1 is not given in the relation. So it is not symmetric. Now transitive. So check, you have three elements. 1 is related to 2 is given here. 2 is related to 3 is given here. But 1 is related to 3 is not given here. So we can say that this relation R cannot have, but 1 is related to 3 here. So it is not transitive. Right, guys? So this is very simple to prove this is equivalence relation or not, because if you learn your all the properties, that means reflexive, symmetric, transitive, then you can prove easily. Right? There is another example here, and this example is, let us assume that F be a relation on the set R, real numbers. R means real numbers, defined by X is a function of Y. That means F is a relation here, and this type of relation is given if and only if IFF means if and only if X minus Y is an integer. So that X and Y belongs to set F, and in relation is here X minus Y is an integer. That means condition is that you have that you have two integers, and that integers are denoted that integers are showing the relation X minus Y type, and X minus Y also be an integer, right? So prove that F is an equivalence relation on R. So first one property is reflexive. So just reflexive property, that means A is related to R. So here X, Y given. So X is related to X and Y is related to Y, right? So consider x belongs to real number. Then x minus y is here. So for the reflexive relation, your property will be x is related to y x. So x minus x is equal to 0, and you know guys, 0 is an integer. So our property reflexive is true for this relation. Now you can check similarly for y is related to y, so y minus y is equal to 0, so y is also satisfying reflexive property. Now symmetric, so consider x and y belongs to r. So we, if x and y belongs to r, that is given, right? So x minus y is an integer. These two lines are given in our question. Thus, we need to check y is related to x. So that means our function y will be y minus x. Our integer value will be y minus x. So thus, y minus x is equal to, you can take minus common, so x minus y. So x minus y is an integer, and negative x minus y is also an integer. So as y minus x is also an integer. Therefore, y is related to x by this relation. Now, last one is transitive. So consider x is related to y, belongs to r, and y is related to z, also belongs to r. Therefore, x minus y and y minus z are integers. Accordingly to transitive property, this integer and condition relation is given x minus y. So x minus y minus y minus z, transitive properties x minus y plus y minus z is equal to x minus z is also an integer, right? So show that x is related to z, thus r is an equivalence relation on r. So our properties are satisfied, then we can say that the x is r is an equivalent relation on, f is an equivalence relation on r, right guys? For the equivalence relation, we need to just prove all the three properties. We need to calculate about all the three properties. No other things have to do. And other thing, I will discuss LHRR, that means linear homogeneous recurrence relation, linear homogeneous recurrence relation with constant coefficient, and other also. So there, these topics will be discussed in our next session, and I will share few examples of these questions, and I will also share uh, an assignment. So you will complete that assignment also. So I think it's sufficient for today, right? Thank you.